We'll now look at functions and what they mean. A function has to be between two sets, so from A to B, is an assignment of exactly one element of B to each element of A. And we write this as f colon A to B. And if B is the unique element assigned to little a, we write f of A is equal to B. The idea is every element of A should map onto some element of B, and it should map onto exactly one element of B. We say that A is called our domain, and the set B is called the codomain. And we also have the range, and this is actually what is mapped onto. So not every element in B may be assigned an element of A, so the range is everything that actually is assigned elements. As an example, if we have this function going from z to z, defined by f of x is equal to x cubed, then this first z right here is called the domain. The second z that it maps to is the codomain. However, the range is actually what things look like. So our range, we have to think about what elements of this look like. Well, we know that 0 cubed is 0, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, etc. We can also do this in the negative direction, -1, -2, -3, etc. And this is our range. It's the things that we actually map onto in our function. If we happen to start with particular kinds of functions, we can add and multiply them. In particular, we need these two functions, f and g, that map from some set A onto the real numbers. Then we can add and multiply. And we do that by saying the addition of f of x, or f plus g of x, is f of x plus g of x. So we would evaluate and then add. Similarly, for multiplying, f times g of x is f of x times g of x. Let's consider these two functions. If I want to find f plus g of x, I need to add them. X squared minus 4 plus 3x minus 2x squared. Simplifying this, I would have negative x squared plus 3x minus 4. I could also multiply them to get f times g of x. This would be x squared minus 4 times 3x minus 2x squared. And we can go ahead and FOIL this. The first terms would give us 3x cubed, the outer terms, negative 2x to the fourth, the inner terms, negative 12x, and then the last terms, 8x squared. We can also talk about the image of a set. So we'll let S be some subset of A, where f is just a function from A to B. We can define f of s, which is the image of the set, as the set of all b's in our set B, such that f of little s is equal to b, where little s is in our big set S. So we can talk about the image of a set where it's just the set of images. For example, we'll have the set A, which is 1, 2, 3, 4, 5, and the set B, A, B, C, D, and we'll define the function by this map. We're going to let S be equal to the set 2, 3, 4. Then we say f of s would be, well, we know that 2 maps to A, 3 maps to D, and 4 maps to C. So it's the set of A, D, C, and you may feel more comfortable writing it in alphabetical order, A, C, D.